Hello students, welcome back. The topic that we are going to learn in this session is measure of dispersion. So let's get started. First of all, we need to know that what exactly a measure of dispersion is. Now, a measure of dispersion is the degree of closeness of the value from some central values, that is mean, median and mode, or in other words, it may be concluded that a central of tendency is a single number to represent a group of data, whereas a measure of dispersion is used to measure difference in the data. We can also say that it is defined as the spread of the values from one another or from some common values. Now that some common values may be mean or median or mode. Alright, so the most common measure of dispersions are range, quartile deviation, mean deviation or absolute mean deviation, variance and standard deviation. So we're gonna cover all these topics line by line, and since I told you all that we will be doing it with all types of data, so that means we will be doing it with random observation. We will be calculating quartile deviation, we will be calculating range for all types of data, that is for ungrouped data, for simple frequency distribution, for group frequency distribution. That is for case 1, 2 and 3. So let's get started. Okay, so the first topic is range. Now how to calculate the range? Now range is the simplest measure of dispersion, and it is defined, or it is the difference between the maximum and the minimum value of the data. Alright, so if you're talking about an example, let's find out range of this particular data. Okay, so this is the data given, and if you need to find out range of this data, what you're going to do is that you're going to take its highest value or highest observation present in the data minus the minimum value, which is the smallest value of the data. Okay, the difference of highest value and smallest value is range. So in this particular example, the highest value is 43 and the minimum value or the minimum observation is 12. Alright, so there is 12 and there is 43. So 43 minus 12 gives you 31. So that is how you calculate range for a simple set of observation, or you can say for case 1 of ungrouped data. Moving on, find range in the following frequency distribution. Now let's say if the frequency distribution is this, like we're talking about case 2 out here. Alright, so for case 2, if set of observations are given, and with each observation there's a corresponding frequency written, so how we will be finding out the range? So the range, the definition of range is pretty clear, that it is the difference of maximum observation and the minimum observation. So what we are going to do is, in this table, the maximum observation, because this x means the observational values, right? These are all observation values, 3, 4, 5, 6, 7 and 8. So the maximum observation is 8 and the minimum observation is 3. So the difference of these two numbers, 8 minus 3, is 5, and that is my range. Since we're not talking about how many times it is repeating in the data, we're only saying that range means the difference of maximum and minimum observation, and if it is written in table form, it doesn't matter. We will be just looking at the observational value, the maximum observation. Since we are going, it's written in ascending order, so the minimum observation is this, the starting value is the minimum observation, the maximum value is this one, the last class observation. Alright, we're not talking about how many times that particular observation is repeated in the data. So that's how you calculate simple frequency distribution range for simple frequency distribution. Alright, so if you wanted to find out range of the following grouped data, now this is my group data and I need to find out range for this data. See, I told you all, and I'll repeat it again, that range means the difference of maximum and minimum observation if the values are divided into classes. Alright, so if you look at this table, okay, in this table these are my observational values. The minimum class boundary is 10, the maximum class boundary is 60. Of this complete table, the minimum value is 10 and the maximum value is 60. All right, so if we need to find out range, so what we're going to do is we're going to take upper class boundary of last class, all right, minus lower class boundary of first class, which will give us range. Okay, so in this case 60 minus 10, which is equals to 50, will be my range. Okay, because see, if you just look at the table, these are my observational values which are divided into classes, and they have asked me to find out the range. So the range is maximum observation, which will always be lying in the last class, because we have divided the data in ascending order. All right, so the maximum observation, so the maximum observation, if it doesn't matter if it is the data is divided into classes, is 60 in this particular table, and the minimum is 10. So 60 minus 10 will gives you 50, and that is how you find out range for all three types of data. We have also done it in organization of data. When we were organizing the data, they were specifically, we need to know that what exactly the range is, and then we proceed with the height. So range is important. It is one of the most important measure of dispersion, but when we are doing organization of data, we need to know the range so that we can easily divide the data into classes, and we can easily need to know that what is the height of that particular so that is how you calculate range for all three types of data. We have also done this in organization of data, but in organization of data it is important because we need to know height for organizing a data. When a data itself is organized and we are asked to find out the range, we'll look at the table and then we'll find out the range, because in this case we're not given simple random observation and we're not asked to group this data. We're just given this grouped frequency distribution and we are simply asked to find out the range, and this is the procedure of finding the range, that you need to take the maximum observation minus the minimum observation. So in this case, the upper class boundary or the upper class limit, okay, the upper class boundary or the upper class interval or the upper class limit of last class minus the lower class boundary or lower class limit of first class. So that is how you calculate range. So moving on, we're now moving on towards quartile deviation or semi-interquartile range. Now, interquartile deviation is situated between the first and third quartiles of a distribution. Semi-interquartile range is a measure of spread. Okay, so basically if we say that what is semi-interquartile range, they are actually talking about the measure of spread, that how the data is spread. All right, and it tells something about how data is dispersed around a central point. Now that central point mainly is the mean we are talking about. Okay, there is one thing called interquartile range. All right, so if they are asking you about interquartile range, so that means they are asking you about the difference of maximum and minimum quartile. All right, so the difference between third and first quartile is called interquartile range, and we are talking about semi interquartile range or interquartile deviation. We are talking about QD is equals to Q3 minus Q1 divided by 2. Let's say if we are only asked about interquartile range, so interquartile range means Q3, that is the upper quartile, minus the lower quartile, that is Q1. So Q3 minus Q1. Why? Because see, we were talking about range out here, and range means maximum observation minus minimum observation. If that range is related to quartiles, so we can say that interquartile range means the maximum quartile, which is Q3, the upper quartile, minus the lower quartile, which is Q1. All right, and if we are talking about interquartile, semi-interquartile range or interquartile deviation, we're talking about QD or SIR is equals to Q3 minus Q1 divided by 2, as it is written that SIR is half of the interquartile range. Okay, so interquartile range is Q3 minus Q1, and half of interquartile range is Q3 minus Q1 divided by 2, which is quartile deviation, or you say semi interquartile range. Alright, so for that we need to find out Q3 first, third or upper quartile, and Q1 first or lower quartile. Now the method for finding quartile is already there in my videos. You can go and check that how to find out quartile for all three cases. In this particular scenario, what I'm going to do is I'm going to directly place the formula and we'll find out the quartile, and we'll proceed towards the quartile deviation, because I've already explained quartile, that how individually quartiles are calculated for each set of data or for each type of data. Now the first example is that we need to find out quartile deviation for the following data. Now this is my data: 10, 13, 9, 6, 4, 9, 18, 8, 7, 5 and 4. These are all together 11 observation. Now if we need to find out quartile of case 1 or of ungrouped data, what we need to do is that we need to array the data first. We array the data, then we will place the formula. Alright, and after placing the formula, we'll look for the position, because that formula actually gives you the position. Okay, we'll go back in the data and we'll find out what is the number present at that position. Okay, so that is how you find out quartile for ungrouped data. Now this was the general formula for finding out quartile. We are only interested in finding out the upper quartile, which is Q3, and lower quartile, which is Q1. So Q1 is equals to 6 and Q3 is equals to 13. Now what you do is that you just verify your answer, or you because the data is given out here. Alright, so you find quartiles on your own and you can check with these answers that are they same or not. Now the process of finding quartile is same as I told in the previous videos. Okay, so out here I've just directly calculated the values. So Q3, the final answer is 13, Q1 is 6. Okay, and if you need to find out interquartile range first, so that is Q3 minus Q1, which is 13 minus 6, which gives you 7, and quartile deviation, that is equals to Q3 minus Q1 divided by 2, which is 13 minus 6 divided by 2, or 7 divided by 2, which is equals to 3.5. So that is how you calculate quartile deviation for an ungrouped data or for case 1 data. Now moving on, we are now moving on towards the second case, which is find quartile deviation in the following frequency distribution. Now the frequency distribution given out here is this. Now this is case 2, or simple frequency distribution, where observations are listed and to every observation there is its frequency count is written next to it. Okay, so as you can see, 0, 1, 2, 3, 4, 5, 6, these are my values, and corresponding to each value there is a frequency count written next to it. Now they have asked us to find out quartile deviation in the following frequency distribution. See, whenever a quartile deviation is particularly asked, the one thing is very clear, that we need to know how quartiles are calculated at first place. Alright, so you need to know that how quartiles are calculated, then only you can proceed with this further, because the main part is calculating quartile. Alright, so as I said that the video for quartile is already uploaded, you can go and check there. So how to calculate quartiles for all three cases, for all three types of data. Okay, since n, which is equals to summation of f, is equals to 113, the total number of observations are 113. So the quartile formula is q of I is equals to I times summation f plus 1 divided by 4, th value. Now if I just go back a little, quartile for this case is calculated, then you need to find out cumulative frequency first. Okay, we'll place the, then we'll use this formula. Okay, and then we will look at the values that after the formulation, that what position they are position is written after the formulation, and then we will look those values in the cumulative frequency column. Then after we will declare our final answer. So in this particular case, I've already calculated the values, and Q1 is 1.5 whereas Q3 is equals to 3. Now what you can do is that you can use this formula and use the method of finding quartiles for simple frequency distribution, and you can easily calculate these two values, which is 1.5 Q1 and Q3 is equals to 3. Okay, you just have to make a CF column first, then you will use this formula, then the position they are describing, you have to look that position into the CF column, and then you will find out the final answer. Alright, okay, so after that the final thing is that we need to use the quartile deviation formula, which is QD equals to Q3 minus Q1 divided by 2. Alright, so in this case it's 3 minus 1.5 divided by 2, which gives us 0.75. Alright, so this is how you calculate quartile deviation for simple frequency distribution. Now in order, I repeat, to find out quartile deviation, you need to know that how quartiles are calculated, because the main thing depends on how quartiles are calculated. This step is majorly important because you need to get these two values correct in order to find out correct quartile deviations. Alright, moving on towards the final case, which is find quartile deviation in the following distribution. Frequency distribution, as you can see, it's a grouped frequency distribution. Why? Because there are the data is divided into classes, and to every class there is a frequency written next to it. Alright, so we are asked to find out quartile deviation. So the main thing is to find out quartiles first. So for group data, we use the formula, which is this one, Q of I equals to L plus H upon F into I times summation F by 4 minus CF. Now you need to know that how to calculate quartile for a grouped frequency distribution. First of all, we'll find out quartile class by using this part of the formula. Alright, then we will look those values in CF, and then we'll came across that what is a quartile class. After that, we'll take that class lower boundary, height, frequency. The CF will always be taken as of preceding class, okay, not of the current class but of preceding class, okay, one above. So CF is always taken as for cumulative frequency of preceding class. Since we are talking about first quartile and third quartile, so the first quartile class, if we have first quartile class, cumulative frequency preceding to first quartile class will be taken. Alright, and if you are looking for Q3, so cumulative frequency preceding to third quartile class will be taken for in this particular formula. To find out values of first and third quartile, okay, so these are the values for first quartile and third quartile. Now you can use this formula for that data and find out the final values, which is Q1 equals to 51.81 and Q3 is equals to 58.14. The next step is same, that Q3 minus Q1 divided by 2. We're going to take the difference of upper quartile value and lower quartile value and divide it by 2. So the final answer is 3.165. Now it is very, very important that for these questions you need to know that how quartiles are calculated. Alright, and if once you know how to calculate quartiles, you can easily solve these questions because it's a one step further. Alright, you need to calculate quartiles first and then quartile deviation. So I hope that you have understood how to calculate range and quartile deviation, and you can easily calculate quartile deviation for all three set of datas now. Thank you so much.